and welcome to this comprehensive tutorial on machine learning and AIOps, where artificial intelligence meets IT operations to automate processes, detect anomalies, and predict potential system failures. As IT environments grow increasingly complex, traditional monitoring and troubleshooting methods struggle to keep up. AIOps, artificial intelligence for IT operations, leverages machine learning to process vast amounts of data, identify patterns, and make intelligent decisions in real time. In this session, we'll start with an overview of machine learning models for AIOps, understanding how different models are applied to IT operations. Next, we'll dive into training algorithms with labeled data, which is crucial for building accurate supervised learning models. From there, we'll explore classification and clustering techniques, which help categorize incidents and group similar system behaviors. We'll also cover anomaly detection using supervised and unsupervised methods, showing how AI can detect irregularities before they escalate into major issues. Moving forward, we'll discuss predictive analytics and forecasting future incidents, where machine learning helps anticipate problems before they impact business operations. We'll also introduce natural language processing, NLP, for log analysis, demonstrating how AI can analyze logs, detect patterns, and automate issue resolution. To ensure our models perform optimally, we'll go through training and evaluating models, followed by model validation and accuracy metrics to measure their effectiveness. Finally, we'll wrap up with fine-tuning and improving models over time, ensuring continuous learning and adaptation in evolving IT environments. By the end of this session, you will understand how machine learning enhances IT operations by reducing downtime, improving efficiency, and enabling proactive incident management. At the core of AIOps are machine learning models that analyze massive amounts of operational data. These models detect anomalies, classify incidents, and predict potential system failures. There are three main types of machine learning models used in AIOps. 1. Supervised learning. This requires labeled data to train models. It's commonly used for incident classification and anomaly detection. 2. Unsupervised learning. This finds patterns in unlabeled data, useful for detecting unknown threats or emerging issues. 3. Reinforcement learning. This helps IT systems learn from past actions and optimize responses to incidents. In AIOps, these models continuously analyze logs, metrics, and alerts to detect unusual behaviors and trigger automated responses. To make machine learning models accurate and effective, they need training data. This is where labeled data comes in. Labeled data means that each data point is already tagged with the correct category. For example, if a system log reports an issue, it can be labeled as a high-priority alert, network failure, or false alarm. By feeding labeled datasets into machine learning models, AIOps can learn what normal system behavior looks like, how to classify incidents correctly, how to differentiate false positives from real threats. The more high-quality labeled data a model has, the better it becomes at automated decision-making. Once models are trained, they use classification and clustering to organize and make sense of incoming data. Classification. This is used in supervised learning. It assigns labels to data points, for example, classifying an incident as critical, warning, or normal. Clustering. This is used in unsupervised learning. It groups similar incidents together, even if the system has never seen them before. For example, a classification model might predict whether an incoming IT alert is a security threat or a system glitch, while a clustering algorithm might detect that multiple alerts from different servers relate to the same root cause. These techniques help AIOps prioritize alerts, group similar incidents, and reduce noise in IT monitoring systems. One of the most powerful applications of machine learning in AIOps is anomaly detection, identifying unusual patterns or system behaviors that might indicate a problem. Supervised anomaly detection. The system is trained with labeled examples of both normal and abnormal behavior. If it sees a pattern matching past anomalies, it flags it as an issue. Unsupervised anomaly detection. The system analyzes data in real time and detects outliers that deviate from normal trends, even without prior examples. For example, if CPU usage suddenly spikes to 99% across multiple servers, anomaly detection algorithms can raise an alert before the system crashes. AIOps doesn't just react to problems, it predicts them before they happen. Using historical data and trend analysis, predictive models identify potential failures days or weeks in advance. For example, machine learning can detect gradual performance degradation in servers and predict when they're likely to fail. IT teams can then take preventive action before an outage occurs. Predictive analytics helps organizations reduce downtime by addressing problems proactively. Optimize IT resources by predicting traffic spikes. Improve system reliability by forecasting failure points. Every IT system generates massive amounts of logs, and manually analyzing them is impossible. Natural language processing, NLP, helps AIOps make sense of unstructured log data. NLP models can extract key information from logs, identify recurring error messages, automate root cause analysis. For example, if thousands of logs report database connection timeout, an NLP model can detect this pattern, correlate it with other system events, and suggest possible solutions. To ensure high accuracy, machine learning models must be properly trained and evaluated. This involves splitting datasets into training and testing sets, testing models on real-world data, adjusting hyperparameters to improve accuracy. Regular training helps models adapt to evolving IT environments, making them more effective over time. To measure how well an AIOps model performs, we use accuracy metrics such as precision and recall, how well the model detects real issues while avoiding false alarms. F1 score, a balance between precision and recall. ROC AUC curve, measures how effectively the model distinguishes between normal and abnormal events. These metrics help fine-tune models to minimize false negative and false positive, ensuring reliable predictions. Machine learning is not a one-time setup. It requires continuous fine-tuning to stay effective. By collecting new data, adjusting hyperparameters, and retraining models, AIOps improves its ability to detect and prevent IT failures. Fine-tuning ensures that AIOps systems evolve alongside IT infrastructures, keeping them resilient and adaptive. To recap, we began by understanding the different machine learning models used in AIOps, and how training algorithms with labeled data helps build effective models. We then explored classification and clustering techniques, which allow AI to categorize and group incidents intelligently. Next, we discussed anomaly detection using supervised and unsupervised methods, showing how AI can identify irregular patterns before they escalate. We also dived into predictive analytics and forecasting future incidents, demonstrating how historical data can be used to anticipate and prevent IT failures. We then explored natural language processing, NLP, for log analysis, where AI helps extract insights from massive amounts of log data. After that, we covered training and evaluating models, ensuring they perform effectively in real-world scenarios, followed by model validation and accuracy metrics, which help measure model success. Finally, we discussed fine-tuning and improving models over time, ensuring continuous learning and adaptability in dynamic IT environments. By applying these machine learning techniques, organizations can automate IT operations, reduce downtime, improve system efficiency, and proactively respond to incidents. Before you go, take your learning to the next level. Click the link in the description to access this lesson inside the MotivaLogic Academy Learning Management System. There, you'll find a quiz for every lesson, hands-on labs, and real-world projects designed to test and strengthen your understanding. While you're there, explore our full catalog of advanced, hands-on courses and downloadable resources, all created to help you move from theory to real-world expertise faster. Ready to gain real industry experience? Work on practical projects, collaborate with other professionals, and build a strong GitHub portfolio that sets you apart and accelerates your career. Click the work experience link in the description below to register your interest. Don't forget to like, subscribe, and share. And turn on notifications so you never miss a future lesson. Thank you for watching.